In this lesson, we're going to look at indicators. Before we do so, let's remind ourselves that an acid, as we learned in the previous lesson, is a substance that produces charged particles called hydrogen ions when in solution. Okay, so the hydrogen ion, H+, and alkalis are substances that result in hydroxide ions when in solution, and the hydroxide ion was OH-. Okay, so we've got hydrogen ions and hydroxide ions. Now, not only do these ions affect things like the taste of the substance, it makes an acid taste sharp and an alkali taste sour, or how they feel to the touch, for example, that it gives the soapy, slippery feeling to alkalis, and the corrosive properties. But these ions also have an interesting effect on certain chemicals in that they make the chemicals change colour. Now, we can make use of this property to help us identify whether a substance is an acid or an alkali, and determine how strong the alkali or acid is. Now, in the first case here, we have a sample of litmus paper. Now, litmus paper normally comes in two colours, either red or blue. And now when you add the red litmus paper to an alkali, it will change to a bluish colour. Red litmus turns blue in with an alkali solution, and the opposite happens with blue litmus paper, will turn a pinky reddish colour when added to an acid. Okay, an acid solution. Now, these are useful in establishing whether something's an acid or an alkali, but they don't tend to be very good at telling us how strong or weak the acids or alkalis are. Now, we will commonly find in chemistry laboratories nowadays the use of another type of paper called indicator paper, which is this yellow paper, and this also comes in a solution, and this uses more sophisticated chemicals than the litmus paper, which are able to change a whole different multitude of colours according to whether the acid is strong or weak. So a typical indicator chart produced by this type of indicator is shown here, and typically in the middle we have this kind of greenish colour is what we call, this is produced by a neutral solution, that's to say, for example, by water, and as we move in this direction, then the solution becomes increasingly alkaline, and as we move in the opposite direction, the solution becomes increasingly acidic. Let's just go back to our acid and alkali solutions, and you can see we've got the acid with the hydrogen ions here present. Now, as I increase the number of hydrogen ions in the solution, then the strength of the acid increases. Likewise, as I increase the number of hydroxide ions in the alkali solution, the strength of the alkali increases, and vice versa. So we have a term in chemistry called the pH, okay, and this really is a measure of the, oops, that's a capital H, and this really is a measure of the concentration of hydrogen ions present in an acidic solution, or hydroxide ions present in an alkaline solution. And so we start off with a pH of 7. Okay, that's the neutral solution, and that really tells us that there is neither an excess of hydroxide or an excess of hydrogen ions in a solution, so they cancel each other out. But as I start to move this direction to pH 8, then the number of hydroxide ions starts to increase, okay, and it gets more and more and just keeps increasing from pH 11, pH 12, right up to 13 or 14, okay, which means a very high concentration of hydroxide ions in the solution. And going the other way, as we move this way, well, pH 6 means we get more hydrogen ions in the solution. So we have an excess of hydrogen ions, and that gets greater as the pH decreases. So we're going down from 4, 3, 2, and it goes right down to 1. Typically, will be a very high concentration of hydrogen ions, which means a very acidic solution.